Alright, I just realized that I recorded this entire video with the microphone unplugged, and so I'm going to start over again. TsString. TsString is a class, one of the most basic and most fundamental classes used in the tutorial videos. And basically, it is a class which manages a single character buffer, which is assumed to be null terminated, as opposed to the standard string that you may have heard about. Standard in the std namespace, there's a string object for this name. This object is not necessarily a null terminated string. However, TsString is always. To declare a TsString means to, in this case, invoke a constructor. And the class itself has, and I always list first in the public section, the constructor set. TsString, this buffer manager, contains 1, 2, 3, 4, 5, 6 constructors. Now, being a basic type, like int, the intent with this class is for it to be able to be used as you would use an integer or any type of basic object. It can be passed by value or by reference to functions. It obeys the standard C rules of assignment. It can be constructed from another of its type, and so on and so forth. Now, I'm not going to go over all of the functions. I just want to give you an overview of the class and the 5 constructors. First is the void constructor, which is a simple declaration like this. This declares an empty string. Okay. And we can, if we like, we can step into this function, this constructor. Now, my current build configuration happens to be, what is it? Let me say, I think it's just debug. Okay, now the default constructor calls a function called default constructor, unsurprisingly. And all that does is set the members of it. The class itself contains 2 members. One is an integer value. Sorry, I'm wrong. One is a size type value called len for length, and the other is a pointer to a character buffer, for a character in this case is either char, C-H-A-R, small letters, 8-bit character, or a wide character, depending, and that depends on the build configuration. The build configuration in this case is debug, and what that means is the character set being used is multi-byte. So 1 byte per character. That's what that means, multi-byte. So therefore, the character member, the pointer to character member is a pointer to bytes. In this case, these T here, these T's, if you don't know, shorthand for T car, okay, resolves the possibility between the following two things. Car, C, okay, now B, C, I don't know, byte characters and wide characters, not wide and wide. In when one writes, suppose one is to write a computer program, and we don't know exactly whether or not we're going to use multi-byte characters or wide characters. Then instead, what we do is we use something called T characters, which through number defining, see, is either going to be a car character type, or in the Unicode case, it's going to be a wide character. It's hard to see it here, but W car means a wide character. Okay, where's T car itself? Well, here it's car. Well, that's how you do that. I was wondering how you do that. More than one type def on the same one with a comma, I see. So car, in our case, cars, it's T car is a car. But if I change the build configuration to a Unicode, then although this thing might not pick it up right away, it hasn't. It's updating its intelligence. It's a IntelliSense database, and when that's done, now it should take us to the new version. So now T car means W car. Well, what's W car? W car is wide character, 16-bit Unicode character. Now, why there's a difference between Mac and non-Mac, I suppose, is because this is not considered. Macintosh compilers don't understand this keyword wcar type. Okay, but this compiler does. All right. So now a TsString may contain wide characters or regular characters depending on the build. And it has 5 constructors. One you just saw does nothing, sets everything to 0. The next get back to where I was. The next one is a copy constructor. Okay, now if you don't know what a copy constructor is, I suggest pick up your go to your local library and pick up a book on C++ and look up copy constructor, and that'll tell you what that is. It's a constructor which constructs an object from another object of the same type, and usually declared this way, taking a reference a reference to an object of the same type of the thing being constructed. Now the reason that one would use a reference rather than just a copy is because we haven't yet defined how to do that copy. This is defining how to do that copy. So in that case, we need essentially a pointer type, a pointer object, and that's what a reference is. It's a fancy way to say pointer, but syntactically not. It also has a constructor from pointer to string. They're pointing to regular characters, either wide or not. And then there are these two special ones that take an extra parameter. First, let me just show you the. We'll go back to just no Unicode here for a second. Something you understand. This here line, if you don't know, is another way of saying this. Well, it's one. Those are one and the same. Those statements are one and the same. Okay, now it's just a matter. It's a syntax thing in the C++ language that you can invoke a copy constructor using the equal sign if it's in a declaration. Otherwise, this equals has a different meaning. So you have to be careful sometimes. This here is a call to the constructor, which takes this type of object. In that case, it's a pointer to characters. Just prove that to you. Okay, I'm going to prove that to you by running up to this point, and I'm going to press F8, and here we are in the constructor which takes a pointer to string. Step out of that. Now we're on this line. Okay, now this here says construct this from this. So this is an explicit, certainly an explicit invocation of that particular constructor. So same line. All right. Now the next is this. Again, the C++ language is written in such a way that the equal sign in a declaration statement means to invoke not any assignment or anything, but to invoke a constructor. Therefore, by the same reasoning, these two lines are the same. We'll invoke the same constructor, the one that takes a constant reference to a string. So I'm going to run up to here and I'm going to prove that again. Sorry, I keep doing that with it. Go away. When I pause the video recorder, it compiles instantly. Otherwise, you gotta wait. So it compiled, and now, so here we are, stepping into not the same as last time. Remember, last time we ended up here. This time we're here, which is the constructor taking a constant reference to an object of the same type we're constructing. At this point, I have an assertion that the object being passed in is not actually the same object we're constructing. That's possible, and that does happen by typo quite a lot. So you want this assertion in your what they call copy constructor. This is a copy constructor. Now, this here is the same as this, but it zeroes everything out. And this part here is just this line with a, I could put that same test, and maybe I should here, but this shouldn't be no. I'd probably check for no in the operator anyway. But anyway, if the string member of the thing being copied from is non-null, then I invoke this plus equals, which is a type of append, but there's nothing just to begin with, so we're appending something to nothing, and so we should end up with this value. So here we are with nothing. We're going to append that, and here we are with some value. Hello world. Okay, now this here, you'll notice, by the way, that I'm displaying the length and the string in this area. There's a way to set this up, and somewhere I mentioned how to do this, but another time. This line should do the same thing as this line according to the rules of C++, and it does. Okay. Now, going back to the tcar thing, there's a macro called _t, which, when placed here around a string literal, changes this from multi-byte to wide-char if the target build is using the wide character set. So if I change to Unicode and I look at my build configuration, I'm using the Unicode character set, and so therefore now this thing will become Unicode. Okay, and so therefore this is a wide character string. Hang on a sec. Okay, so this is a wide character string, and but everything else is the same. Here it's exactly the same. The T thing changes when I change to wide characters. This now means wide characters. Although you can't tell from the value passed in, you can check in memory and you can see those are wide characters. Alright? Now, I personally prefer to be able to see that on this side as well. So that's why I put a little L in my debug display. When the string is a wide character string, I put an L here. The length is still the same. Oh, and of course, this is all the same. Okay. So those are two constructors: copy constructor, constructor from the character type, which is of the same type that this object contains. Now this next one is the only one that is really, well, there are two that are kind of some interest in that they behave differently than the standard string I mentioned before. This standard string has a constructor similar to this, okay? Taking a pointer to the data type, a string of the data type, wide characters or regular characters, and then I think it's unsigned integer value length. Okay. Now, in the standard string version of this type of constructor, this length here, value here, is the correspond to the number of characters A that the string will have in the end, and copied from this buffer. That is to say that if this is 50, suppose I had a standard string, I don't know the syntax exactly, but and I passed it in some other pointer to T card, and I said 156, right? Then stir here is going to be 150 characters long, null terminated or not, doesn't matter. These are not null terminated. These types of strings are not null terminated necessarily, whereas these ones are. And it will copy exactly 150 characters from this pointer. And this is a pointer to the type of character that this thing contains. The TsString version of the same constructor does not behave in that way, and for a very good reason. A, because this is these strings are C strings. Again, I've just made that decision. A TS string is a C string, therefore it is null terminated always. The pointer within the string, within the object, is null terminated. I decided. Doesn't have to be, but I've decided that it will be. And the 156 here says to copy no more than this many characters from here. And if this thing being a C style string, and it should be, but it doesn't have to be. If it's a C style string, meaning it's null terminated, when the null is reached, then the copying halts. For instance, going back to hello world, LPCT stir long pointer to tcard PTC equals to constant. In this case, it's important. It's important here in this case. Let me just spell it out explicitly. Okay, the const here refers to the elements of PTC, not PTC itself. That can change. But these elements are, by this keyword, intended to not be modified. In fact, if you tried to modify the elements of this pointed to by this, your program would crash. Now, if I now try to create a TS string from that, okay, of at most 156 characters, I won't get 156 characters in that string. I'll only get everything up to the D and a null terminator. And the null terminator will not be taken from here, even though this happens to be null terminated. Let me show you just so you understand what I'm talking about. Now I'm going to do this quickly. It's a keyboard macro. Quote, slash, no, not that. Underscore T, great, quote, neck, quote, close, comma, record. I'm just trying to rerun the macro. It still works. Sometimes it does this stupid thing. Okay. Now this is an array. It says hello world with a space. Let's try to make it look like hello world to you. Okay. Now that certainly is a pointer to a character array. T cars in this case, doesn't matter if you're Unicode or not. Currently in Unicode. Let's go to regular. No Unicode. Build this. Now, this is not null terminated. We want something lesser. Let's suppose this is null terminated. But I want my characters. I know. Forget the null terminated. Okay, how about that? So I would like to copy from PTC the number of elements of that array of characters. Right? Now this is important in this case because although this is a string, it's not null terminated, it's not a C-style string. And we don't want to crash. Now, how would we crash? We could crash if the next byte was not in readable memory. And I don't know how to simulate that quickly, but let's just see what happens. Okay, so here we are. Now here's PTC. You'll notice that it is not a null terminated string. Okay, the bytes following it are CC, and now I'm going to construct a TsString. So I'm just clearing out the redraw. That is of length. The length of this array, not the length of the string, because it doesn't have a length. All right. Now how does that work? Now, first off, I want to take care of every possible case. I would like to have at most this many characters, right? But in general, it might not be that this thing might have a 0 somewhere, and I want to stop when I hit a 0. Unlike the C standard version. Alright, default constructor, move everything out. Now, you'll notice that this is an integer value. And the reason for that is because I had considered, and I still am considering, that negative might mean, just all of it. So you don't have to know the length. Right? But we have that already, so let's see. Point. Now I'm using a special function, which is a safe type of length function that you can call on a pointer to some data, and what it returns to you is the length of this string up to, but not including anything beyond that length, right? So now it turns out it does have 11 characters, and this function will not read the 12th character from this string. It's going to quit its scan either when it hits a 0, which is what I want, or when it hits this maximum, and it returns 11. So if this were not readable memory, like if it were at the end of a segment, or a page of memory, in a map file or something, it would not read the invalid memory beyond. Now all I'm doing now at this point is this allocates a buffer of this length plus one more for a null terminator. So here's my buffer, and here's the hello world buffer. Now if you zoom in, if it's possible, I don't know, there's a zoom tool on here, but you'll notice that this buffer that I just allocated has one extra character. Well, when I do the mem copy, you'll see it. See? Hello world, and then there's one extra character unused. This brace is making this not line up properly anymore. Now, these line up pretty good. Maybe if I can do the watch. Okay, that's good. Okay. Well, I can cast that. Come on. Oh, no, double click. It's possible anyway to make a cast, and then these would have lined up. Oh wait, I know. Okay, now they're lined up. So you can see that the allocated buffer, right, includes everything. I've already copied everything up to the D, and my allocated buffer has one more character, and that's where I intend to put the 0, which I'm going to do right now by pressing F11. Now you can't see the rest anymore. I could just put this here. Hello world, and that one's got a 0. Now the length is the length we already calculated. Okay. So here we are back in main. Our string is a properly null terminated string of length 11, but PTC is a non-null terminated string that contains 11 elements. Alright? Now that's just exactly what the standard string thing would have done, except it would not have added the null terminator that I have. And that's because I specified this value here. But now consider this case. Sometimes you might have a long pointer to string. PTC. I don't know. Get long string. Some big long string that you retrieve from a file, right? And all I want to do is print out the first 20 characters, right? So I want to do this. I want to do that. Okay, if it's 100 kilobytes, I don't want to print, and I'm trying to make a little pop-up balloon, let's say, that gives you the first few lines of the file. I certainly don't want to take the whole file. I just want the first 20 characters, and that's great. And that's what the STL thing does too. It takes exactly that many, in fact. And even if it's null terminated before 20. The problem, though, is again going back to a case where a string is null terminated, not like the array case, like that. And let's suppose I want the first 500 characters, right? Well, this one's null terminated, right? But it's definitely not 500 characters long. And I certainly don't want my string to copy 500 characters from this point, because it's going to eventually, it's going to hit all kinds of stuff along the way. So I don't want that behavior. Null terminated things, I want to remain null terminated and to retain their length in the string up to the value I've given. So it contains a safety in that case. In the case where the buffer might be a null terminated string and the number provided exceeds the buffer's capacity. And lastly, second to last, constructor-wise, very simple character, pass in a character and the number of times you want to repeat it. So like I'll be careful and I'll use my keys. If I want to, let's say 35, unsigned. This one unsigned, because generally you don't repeat things a negative amount of times. The T car, meaning unknown type, unknown until we compile whether it's wide characters or not. The version of put_s for T cars has this name. So this might be put_s or put_ws. So I should get 35 letter A's. And there they are. Okay, now you could imagine how that works. Now this is actually particularly useful for when you want to pad things. You want to put some, let's say I call this a tab. The tab might be 3 spaces, so I might have a string hello, and then I might add the tag world. It turns out that this string type, you can add strings to strings in just the way that you can add integers. together. And it's designed to be that way, a very simple, a very simple interface, so you can copy, you can add, there's no subtract, you can append, and do various things, and not have to worry too much about the syntax. It's natural syntax. So here's hello, and then 3 spaces, and then more, just as you would expect from that line. Now lastly, the last constructor, I guess it's my time. What this last one is depends on your scenario. Here we are building for in the non-Unicode environment, right? Suppose I have a pointer to wide characters, right? And I know it's a pointer to wide characters, but I'd still like to extract this string into my TsString. Now I could have made a constructor that takes wide characters in the case where we're not using wide characters, like this. And that's what that constructor does. However, it won't allow you to do it like this, because it's declared to be explicit. I can take wide characters and turn them into multi-byte, but I have to be explicit about it. And the reason for that is to prevent automatic conversions from the wrong data type to a string. For instance, you might have a function which takes 16-bit values for something, and you certainly wouldn't want those to be converted to strings automatically. In this case, I do. So I would have to say cast this as a TsString, and that casting will invoke the constructor. Now, this is how you explicitly invoke a constructor, generally, right? But a regular C-style cast is the same as invoking an explicit constructor. Now we're in the multi-byte world, so this should compile. Stir happens to have a cast to its type, to a pointer of its element types, and so this does compile. And let's run up to here and step into here. It has invoked a special constructor that does a conversion from one type to another. And now this string is not a wide character string. It took this wide character string and converted it. Here's PWC, wide characters. Here's this string, not wide characters. Hello world. Now it all works in reverse. If you happen to be in the Unicode world and you have a multi-byte string, you can use exactly the same syntax to convert to the type of characters that you're using. And that the fact that the syntax is the same can be quite handy in certain scenarios where you're not sure what type of character values you're going to be receiving, but you know exactly what you want to return, and so you can use this cast to make sure that you return the right type of thing. An example is path names. Path names should always be in wide characters, So if you have a function that does the correct thing and retrieves path name for something or other and wants to return to the user what you found, then you simply make this cast, and regardless of what the type originally was, the return value will be in the correct format. And that's it for the constructors. Next, I will go on to the various manipulations you can do with these strings, such as what you just saw, adding things on the left and on the right, changing the case, putting quotes, extracting bits, and so on. See you.